Welcome back, children. Next we can do exercise 16.3. The first question. A card is selected from a pack of 52 cards. How many points are there in the sample space? Calculate the probability that the card is an ace of spades. Calculate the probability that the card is an ace and black. So the experiment is from a pack of 52 cards, taking one card. So the first question is, how many points are there? Points means sample points. That means outcome. The another word for outcome is sample point. So in a pack of 52 cards, we can take one card in 52 different ways, isn't it? So how many outcomes are there? How many outcomes? 52 outcomes. Okay. So the first answer is 52. How many points are there? Points means sample point, that is same as outcomes. Now the second one, calculate the probability that the card is an ace of spades. So the 52 cards is divided into four types. One is spades, clubs, diamonds, then hearts. In each suit there are 13 cards. In that 13 card, one king, queen, jack, ace, then 9 number cards. That way is the division. So in spades, how many aces? Total there are 4 aces only. One in spade, one in club, one in hearts, one in diamonds, like that. So in spade there is only one ace. So the required probability is 1. Favorable outcome is 1 out of what? From the pack of 52 cards we are taking the card. So total outcomes or sample points, that's equal to 52. Okay. So you have to write 1 out of 52. Don't write 1 out of 13, that is wrong. We are taking the card from the packet of 52 cards. Okay. Now C first one. Probability that the card is an ace. So ace, how many aces are there? How many favorable outcomes? There are 4 aces, but we are taking only 1. So favorable outcomes are 4 out of 52. Then black cards. How many black cards? 26 black cards are there. So 26 out of 52. 26 black and 26 red. You can simplify that. 26 by 52 is 1 by 2. Here it is 1 by 2 and this one is 1 out of 13. Now second one, a fair coin with 1 marked on one face and 6 on the other and a fair die are both tossed. Find the probability that the sum of the numbers that turn up is 312. So first you have to understand what is the experiment. Fair coin means equal chances to get. Usually for coin, one side is head, the other one is tail. But here in the coin, one side is the number 1, the other side is 6. Okay. So one coin, not head and tail, one, the other side is 6. Then we have a die. For die we have numbers 1 to 6 and both are tossed. So what is the sample space? First you think about the sample space. Fair coin means equal chances to get 1 and this number 6. Okay. So favorable, the sample space, the set of possible outcomes. I can get 1 with the 1, isn't it? 1 in the coin, 1 in the die. 1 on the coin, 1 on the die, 1 on the coin, 2 on the die, then 1 3, 1 4, 1 5 and 1 6. The other side of the coin is 6, not 2, it is 6. So 6 on the coin, 1 on the die, 6 2, 6 3, 6 4, 6566. Okay. Now getting sum 3. Sum 3 means this is the case. So it is 1 out of 12. Now the second case, sum is 12. Sum is 12 means 6, 6. So it is 1. Favorable outcome 1 out of 12 outcomes. Total 12 outcomes. So first number from the coin, the second number from the die. In that order you have to write. Next one. A fair coin is tossed 4 times. A coin tossed 4 times and a person win rupees 1 for each head and lose rupees 1.50 for each tail that turn up. From the sample space, calculate how many different amounts of money you can have after 4 tosses and the probability of having each of these amounts. Okay. So the sample space is coin is tossed 4 times. Fair coin means equal chances to get head and tail. So 4 times, what is the sample space? 4H, then triple H and 1T, then HH, TH, HT, HH, TH, HH, then double H, double T, HTTH, THHT, then THTH, HT, HT, then double T, double H, then H and triple T, THTT, TTHT, TTTH, then 4 T's. So total 16 outcomes. 1, 2, 3, 4, 5, 6, 7, 8. 16 outcomes. Now for each head, when we get head, what we get? Rupees 1. When we get tail, we lose. That means you have to put minus sign. How much rupees? 1.50. So in the first case we gain or we win rupees 1, the other case we lose rupees 1.50. So in that way you calculate for each outcome how much money we get. So for 4H, the first outcome is 4H. For this 4H, how much money we get? For each head rupees 1. So 4H rupees 4 we get. Okay. Now look the cases. Triple HT, here also triple HT, triple HT, triple HT. 4 are there. For triple HT, how much rupees? That is, I am writing just first outcome, triple HT. So for 3H, 3 rupees. Then from 3 rupees, we have to subtract 1.50. That is equal to 1.50. So for triple H and 1T, rupees 1.50. Positive only? Positive. So like this, how many outcomes? 4 outcomes are there. Okay. Now the next is double H and double T. How many outcomes are there? Double H, double T. There are 6 outcomes are there. Then how much money for that? Double H means 2 rupees. Okay, 2 rupees. From that subtract double T. For 1T we lose 1.50. So for 2T, 1.50 into 2, that is 3 rupees. So 2 minus 3 means minus rupees 1. Okay. So that means rupees 1, that is minus. Now which case? triple T and 1H. Okay, triple T, 1H. That is 4 cases are there. 4 cases, H and triple T. So for H, rupees 1 rupee and minus 3T. So 3 into 1.50, that is 4.50. So the rupees is minus 4.50 minus this is minus 3.50. Isn't it? So here minus rupees 3.50. And the last case, that is 4T. That is only one case. 4T means 4 into 1.50. That is 6. But it is negative. So it is minus 6. Minus 6. So these are the possible amounts. Now we have to find the corresponding probability. So here I am writing let X denotes the number of heads. Okay. So probability of X is equal to 4. That means number of heads 4. That is the first case. Number of heads 4, and we are writing the probability based on the amounts. Okay. So X is equal to 4. That is the one case. Then X3 here, X2 here, X1 and X0. Based on head I am writing. So X is equal to 4. That is rupees 4. How many outcomes? It is 1 only. So 1 out of 16. 16 outcomes are there total. Now what is P of X is equal to? So for this 4 rupees, the 4 rupees for that amount, what is the probability? It is 1 out of 16. Now I am writing X is equal to 3. X is equal to 3 means 3 heads and 1 H. So the amount is 1.50. So 1.50, what is the probability of that amount? So X3, 3 heads corresponding to 3 heads are in 4 outcomes. So we can write it is 4 out of 16. Now what is P of X is equal to 2? 2 heads and 2 tail. So the net amount is minus rupees 1. That is correspond to what is the probability? There are 6 favorable outcomes by total 16. Now P of X is equal to 1. X is equal to 1 H and triple T. The amount is minus 3.50. So what is the probability of this particular amount? 4 out of 16. Now the last one, P of X is equal to 0. That is 4T. The amount is minus 6 and only one outcome out of 16. And look, each probability of each event is greater than or equal to 0. What is the total value? Add everything. 1 plus 4 is 5. 5 plus 10 is 15. Plus 1 is 16. 16 out of 16 is 1. Okay. The next one. In a lottery, a person chooses 6 different natural numbers from 1 to 20. And if these 6 numbers match with the 6 numbers already fixed by the lottery committee, he wins the prize. What is the probability of winning the prize in the game? So 1 to 20 natural numbers are there. The person has to select 6 natural numbers. So from this 20 numbers, selecting 6 numbers, in how many ways we can select? The number of ways of selecting or choosing 6 numbers from 20 numbers. How we write? That's equal to NCR. Remember, 20 C6 from 20 numbers. We have to select 6 numbers. The notation is this. So this much way we can select 6 numbers. And in your textbook it is given that order is not important. So permutation, that case we don't want to take. Only the selection. So from 20 the person has to select 6 numbers. So 26 different ways he can select the numbers. So that much ways. Now the price is for only one number. Which 6 numbers the person chooses, if that matches with the already fixed numbers, then only he get the price. So the price is for only one number. So what is the required probability? Required probability is equal to, favorable case is only 1 out of this much ways, 20C6. Okay, we can calculate what is 20C6. How to find 20C6? 20 factorial by 6 factorial and 14 factorial. So that is 15 into 16 into 17 into 19 into 20. Okay, by 6 factorial. 1 into 2 into 3 into 4 into 5 into 6. 6 3s are 18. 18 cancel. 4 into 2, 16, 2. Then you have to multiply. Okay, so multiply and write the answer. Now the next one, check whether the following probability is consistently defined. First case, P of A, P of B, P of A intersection B is given. Is that is correct? That's the question. So from this we can calculate what is P of A union B. P of A union B is P of A plus P of B minus P of A intersection B. Okay, that is possible to find. 0.5 plus 0.7 minus 0.6. That is 1.2 minus 0.6. Okay, that's equal to 0.60. Okay, 0.6. Now, this P of A intersection B is 0.6. It is greater than P of A. Is it possible? A intersection B means the common in both A and B. So it can be, A intersection B can be P of A intersection B must be less than or equal to P of A and P of B. Intersection cannot be greater than P of A and P of B. That is not at all possible. Okay, but here it is given A intersection B is 0.6 but P of A is 0.5. That is not possible. So this probability, the first case, not consistently defined. Therefore, this given probability is not consistently defined. Why it is not defined like that? Since P of A intersection B is greater than P of A. Now the second case. Is there any problem in the second case? P of A, P of B. Here P of A union B is given. So P of A union B is P of A plus P of B minus P of A intersection B. So what is P of A intersection B? P of A plus P of B, that is 0.5 plus 0.4, then minus A union B, that is 0.8. That is 0.9 minus 0.8. So that is okay, 0.1. So the second question that are consistently defined. It is consistently defined. Okay, since we get the value, it is not negative value, we get a proper value there. Okay, but in the first case, P of A intersection B is more than P of A, that is not possible. Next one, Even C and F are such that P of not E or not F is 0.25. State whether E and F are mutually exclusive. So, for finding whether E and F are mutually exclusive, we have to get intersection E intersection F. So, what is given? From that we can start. P of not E or not F. What is the notation? E complement union F complement. By De Morgan's law, it is same as E intersection F the whole complement. And P of A complement is 1 minus P of E intersection. Okay. And this part is given as 0.25. So, what is P of E intersection F? It is 1 minus 0.25. So, it is 0.75, isn't it? Subtraction, that is P of E intersection F. That is P of E intersection F not equal to 0. If it is equal to 0, then E and F are mutually exclusive, isn't it? E and F are mutually exclusive, means E intersection F is equal to null set. So, the probability, the corresponding probability equal to 0. Okay. But here the probability is not 0. So, what we can conclude? Therefore, E and F are not mutually exclusive. Not mutually exclusive. Okay. The next one. If E and F are even such that P of E, P of F, P of E and F. E and F means intersection. Then find P of E or F, P of not E and not F. So, P of E is given, P of F is given, then P of E intersection F is given. Have to find P of E or F. What is the notation for or? Union, E union F. What is the formula? P of E union F is P of E plus P of F minus P of E intersection F. Now you substitute 1 by 4 plus 1 by 2 minus 1 by 8. So 8 is the LCM. 2 plus 4 minus 1, that is equal to 5 by 8. Now what is P of second one? This is the first one. Second one, P of not E, the notation E complement intersection F complement. That is same as by De Morgan's law, E union F the whole complement. That is same as 1 minus P of E union F. So it is 1 minus 5 by 8, that is equal to 3 by 8. Okay. The next one, in an entrance test that is graded on the basis of 2 examinations, the probability of randomly chosen student passing the first examination is 0.8. Probability of passing the second examination is 0.7. The probability of passing at least one of them is 0.95. What is the probability of passing both? So we have to define the events. Let E and F. E means the student passing the first examination. F means passing the second examination. So P of E1 is given 0.8, P of E2 is equal to 0.7. Then what is this? At least one of them. At least one of them is same as either E1 or E2, that is the meaning. So it is given that P of not E1, sorry, it is E and F only to denote. P of E, P of F. So, E union F is given as 0.95 and we have to find the probability of passing both, that is E intersection F. Both means intersection or means union, at least means union. So, now we apply this. P of E union F is P of E plus P of F minus P of E intersection F, that is P of E union F. So, what is P of E intersection F? P of E plus P of F minus P of E union F. 0.8 plus 0.7 minus 0.95. So, 8 plus 7 is 15. 1.5 minus 0.55. So, it is 0.55. The next one, in a class of 60 students, 30 opted for NCC, okay, National Cadet Corps, and 32 opted for NSS, National Service Scheme, and 24 opted for both. If one of these students is selected at random, find the probability that the student opted for NCC or NSS, the student has opted neither NCC nor NSS, the student has opted NSS but not NCC. So, here probability is not given, we have to write the probability. So, A and B, anyway you can define, let E be the event, the student opted for NCC, F be the event, opted for NSS. So, what is P of E? How many students opted for NCC? 30. Favorable is 30 by total. Don't forget to write the total. Total in the class 60 students are there. So, P of F is NSS 32 by 60. Then 24 opted for both. So, both means intersection is given. P of E intersection F is equal to 24 out of 60. Now, what is the first question? We have to find NCC or NSS means the notation E union F. P of E union F is equal to P of E plus P of F minus P of E intersection F. 30 by 60 plus 32 by 60 minus 24 by 60. So, 32 minus 24 is 8. So, 38 by 60 or it is 19 by 30. Now, the second one, the student has opted neither NCC nor NSS. So, P of neither nor means E complement intersection F complement, that is P of by De Morgan's law E union F whole complement, that is 1 minus P of E union F. So, 1 minus 19 by 30. So, it is 11 by 30. Okay. 30 minus 19 by 30. Now, the last one, the student opted for, the student opted for this one. The student has opted NSS but not NCC. NSS but not NCC. So, what is the symbol? NSS but not NCC. NSS is F. NSS but not. So, minus E. Okay, but not symbol is minus. So, P of F minus E, how to find that? Venn diagram, E F. F minus E. F minus E means this shaded portion. Okay, that is F minus E. How to find that portion? From the whole F we can subtract E intersection F. So P of F minus E intersection F. Okay, so that's equal to P of F minus P of F minus P of E intersection F. In the F total there are 32 by 60 minus that common both NSS and NCC is 8 no 24. It is 24 out of 60. So it is 32 minus 24, that is 8 out of 60. Can cancel by 4. Okay, so that's the answer. Okay, so you have to remember or at least means union symbol, both means intersection symbol, then neither nor is intersection of their complements. Okay, then A but not B, that is A minus B. So from A you have to subtract the common portion.